Okay, good morning. So today we will be looking at graphs out of exercise 1 on page 71. Okay, so the first one is dealing with some theory in 1.1. We're told that the standard form of a straight line is y is equal to mx plus c. Okay, so the question is, what does m represent? M is your slope or your inclination or your gradient. Okay, C 1.2, what does C represent? C is norm dy intercept, where the graph cuts the y-axis. Okay. 1.3, the question says, draw a graph for C is less than 0. This means to say C is negative. If something is less than 0, it's negative. Okay, and M is less than 0, which means to say M is negative as well. Okay, so we know the graph will be drawn on an axis of symmetry. Okay, that's your y-axis and your x-axis. That's your origin. We always tend to write that information down. Anyway, on the side of the axis is your x. Your x is negative. On the side, x is positive. That's why we said earlier on, if something is less than 0, as you can see here, less than 0 is negative, more than 0 is positive. This above the line, y is positive and y is negative. So they say y is less than 0, y is negative. Your c value is negative. It can be anywhere here. Since it wasn't defined, we just put c there. Then we are told that m is less than 0, so m is negative. So your gradient or your slope or your inclination is negative. So it's a decreasing function. So the graph would look something like that, or like that, as long as the gradient is negative and your c value is negative. In 1.4, the question says, draw the graph where c is equal to 0. Okay? And so if c is 0, it's going through the origin, or your y-intercept at 0, and your gradient is greater than 0, which means to say your gradient is positive. Okay? So if we draw that graph again, it will be on your axis, your Cartesian plane. And at this point, you already explained to you what the Cartesian plane is and how it works and all of those things. So you see 0, so it has to go through it like that, or like that, or however, but it has to go through the y-intercept of 0. And your gradient is positive. Gradient is greater than 0, so it must be an increasing function. Remember, if the gradient is positive, it's increasing. If your gradient is negative, it's decreasing. Those arrows indicate that the graph just carries on. Okay. Now we're looking at number 2. The question says, draw the graphs of each of the following. Okay, so what I'm going to do is I'm going to take out all the odd numbers and I'll draw these graphs for you. Okay, let's start with 2.1. The graph is y is equal to 2x minus 2. So there are different ways of drawing these graphs. The one is by using a table. Another is by using the dual intercept method. And the other one is doing the rise and run, which is the gradient y-intercept method. The easiest method to use, to me, is the dual intercept method. Dual means 2. Intercept is basically is cutting your intercept or your axis. Okay, is crossing your axis, intersecting with your axis. So to do the dual intercept method, we work out our x-intercept. What do you do for x-intercept? We let y equal to 0. Why do you let y equal to 0? Because anywhere on your x-axis, we have a y value of 0. Okay? Anywhere on your y-axis, we have an x value of 0. That's why when we say, where does the graph cut your x-axis? By letting y equal to 0. Okay? So we then say 0 is equal to 2x minus 2. Now this becomes an equation. So we take that over, so negative 2x is equal to negative 2. So x equal to 1. Then we do our y-intercept. Y-intercept, let x equal to 0. Okay, so y is equal to 2 times 0 minus 2, which is 0 minus 2, which is negative 2. Okay, so you're going to cut your x-axis at 1 and your y-axis at negative 2. Again, we draw the graph. X value of 1. So this is by approximation. Y value negative 2. Now we're not going to make negative 2 the same size as 1. It must be about double that size. So this is by approximation. There we go. Okay. In 2.3, we have y is equal to x plus 5. Again, we go y-intercept. We let x equal to 0. Okay, so we say y is equal to 0 plus 5, which then gives you 5. Okay, x-intercept, let y equal to 0. So we got 0 is equal to x plus 5. We take the 5 over, it becomes an equation, so x is equal to minus 5. Okay, you could have worked out your x-intercept first or your y-intercept, it doesn't really matter. Again, you come to a point where we're going to draw the graph. Here's your y, your x. This is your 0, your origin. Y is 5, approximately there. And x is minus 5. You can see it's about the same. Okay, as again, approximation. Don't make all that dots, the strokes and all that. Okay, it's going through that point of 5 and through that point of minus 5. Alright. 2.5. Y equals negative a third x minus 1. Again, y-intercept. Let x equal to 0. So you got y is equal to negative a third times 0 minus 1, which is negative 1. Your x-intercept, let y equal to 0. So you got 0 is equal to negative a third x minus 1. We'll take it over. So it's a third x is equal to negative 1. Divided by a third both sides. So x is equal to negative 3. Okay, so let's draw. So y, x, 0. So your y is negative 1. X is negative 3. There we go. So let's look at the gradient and the graph. You see this gradient is negative, right? What do you notice about the graph? It's decreasing. As x increases, the graph is decreasing. Okay. The previous equation was y equals 2.3. Y is equal to positive 1x plus 5. What do you notice the gradient is? Positive. The graph is increasing. So here the graph is increasing, so the gradient has to be positive. As you can see here, we had y is equal to 2x minus 2. The graph, the gradient was positive, increasing. Okay. So knowing the gradient, we can see more or less if our graph is correct. If we had made any mistakes in our calculation. Okay, the next one is 2.7. We got 4y minus x plus 8 equals 0. So we go x-intercept, let y equal to 0. So you say 4 times 0 minus x plus 8 is equal to 0. We drop that, so negative x plus 8 is equal to 0. So x is 8. Now we go y-intercept. What do you do for y-intercept? Let x equal to 0. So you got 4y minus 0 plus 8 is equal to 0. So you got 4y is equal to negative 8. Okay, so y is equal to negative 2. We'll draw the graph in the next video.